The next topic is one of the key topics in C1, and it's differentiation. But before we can differentiate, we've got to sort out this mess here. So if we write it as 3x squared plus 6x to the power of a third, and then we rewrite this so, plus 2x cubed over 3, instead of writing square root of x, we write x to the power of a half, minus 7 over 3 x to the power of a half. So all we've done there is we've separated this into two parts and put 3 root x on this side, 3 root x on this side. So then what we've got to do is put this in a form so that you've only got an x on the top. So y equals 3x squared plus 6x to the power of a third plus 2 over 3. X cubed divided by x to the power of a half, you just need to subtract the powers. So that's going to be 2.5, which is x to the power of 5 over 2, minus 7 over 3. Notice that the 3 stays on the bottom. If we bring the x at half up to the top, that's going to be x to the power of minus 1/2. Then we simply got to differentiate it. So dy by dx, what we do is we bring the power down. So that's going to be 6x. And we've got plus 6 lots of a third is going to be 2. Then we take away 1. So a third to take away 1 is a third to take away 3/3. So that's going to be minus 2/3. Then we've got 2/3 times by 5 over 2. So to one side, 2/3 times by 5 over 2 is going to be 10 over 6, which simplifies down to 5/3. So it's going to be plus 5/3 x, and then we've got to take away 1 from this power. So take away 1 from 5 over 2. So 5 over 2, if you take away 1, that's taking away 2 over 2. That's going to be 3 over 2. And then you've got minus 7 over 3 times by minus 1 over 2. So minus times minus is going to be a plus. And 7 times 1 over 3 times 2 is going to be 7 over 6. You're going to take away 1 from that, so take away 2 halves again. It's going to be the power of minus 3 over 2. And that's it. That's how you differentiate. So that was the 2016 paper. The 2015 paper, we've already done the integration part of this question, so let's have a look at the differentiation. And just like before, we can't have x squared on the bottom, so we need to bring it up to the top. It's going to be x to the power of minus 2. Remember, when you bring it up to the top, you make the power negative. So you're then going to bring the power down and take away 1 from the power. So that 3 down to the bottom is going to be 12x squared. Then bring the minus 2 down to times by minus 5 is going to be plus 10x to the power of minus 3. Don't put the plus in because that's when we integrate, and this is differentiation. Okay, similarly with this one, we can't differentiate at the moment because we've got them as powers. So we need to simplify this by multiplying out the brackets. So just like in the previous videos, if you've got a squared bracket, you write out the bracket twice. So that's going to be, using whichever method that you want to expand quadratic brackets, 1 minus 2x minus 2x plus 4x squared. So 4x squared minus 4x plus 1. That equals y. So dy by dx equals 8x. If you differentiate minus 4x, that simply goes to minus 4, and the number just disappears. So it's going to be dy by dx equals 8x minus 4. Again, just like we did last time, we're going to split this into two fractions. So that's going to be x to the power of 5 over 2x squared plus 6x to the power of a half over 2x squared. And then we're going to simplify that. So the half stays on, the 2 stays on the bottom. If we subtract the powers, that's going to be x to the power of 3 over 2. And then if we simplify 6 over 2, that's going to be 3. Half take away 2 is going to be minus 1.5, so it's going to be minus 3 over 2. And then you differentiate. So if we say that's y equals dy by dx, you bring 3 down, and that's going to be 3 over 2, x to the power of 2. If we bring minus 3 over 2 down, that's going to be minus 3 times 3 over 2 is going to be 9 over 2. If we take away 1 from this, we take away 2 halves, So it's going to be x to the power of minus 5 over 2. And it's really easy to make a mistake there. So just take your time and just make sure you go through that over and over. Okay, and that's how to do differentiation questions.